What is a function? A function is a correspondence between a first set, called the domain, and a second set, called the domain of the range. Another way of looking at it could be said, basically, for any member of the domain, there corresponds exactly one member of the range. What basically they're talking about, let's look at it as though it's a set of points. And we'll just kind of look at it as a set of points, so that maybe you can understand it a little better. Basically what they're saying is that I have an X, and let's right now, for this purpose, call it a Y. It's saying that I will only have one X that corresponds to the Y. And because we are talking about a function, we can't use X and Y, so what they're calling it is that I have a domain and I have a range. Same idea. For every one domain, there will only correspond one range. I came up with about 4 examples, just so that maybe you can understand what we're talking about a little bit better. Okay, let's look at the first one. If you look at the first one here, let's consider this the domain. And I said for every domain, there corresponds only one range. So if you look at it here, you have an A and a P, and an A and a T. Notice here, the A and the P and the A and the T correspond to what? One domain corresponds to 2 different ranges. So therefore, we do not have, for this particular one, this is not a function, because it said that you can only have one domain corresponding to one range. Notice here, this is okay, and this one is also. But it's the A that makes number 1 not a function. Now let's look at B, number 2. Notice here the domain and the range. Here I have 1 that corresponds to A, 2 corresponds also to A, and 3 to B, and 4 and 5 will correspond to the C. But according to the definition, it's okay if 2 different domains go to one range, but it's not okay if we have one domain going to 2 different ranges. Do you see the difference between the two? This is not a function. This is a function, because it doesn't matter if it's going to the same ranges. It's just that the domains can't repeat. So this is a function. This is not a function, and this is a function. Now let's look at the last 2 I created. Here we have cats and fish and dogs and so forth. Now take a look at each one. Would you consider this to be a function? Looks like it would be a function, because notice, here's my domains, and each one of them will only go to what? One range. So this is a function. But if I look at number 4, is this a function? No, it's not. Because if you look at each one of your domains, which we consider this, there's a repeating domain going to what? 2 different ranges. So because of this capital D going to B and to D, this is not a function. So let's recap what we just said. There cannot be any repeating domains going to ranges. Let's look at another concept that they've also created for you. Another one then that we'll kind of look at is something called the notation for a function. So we have a notation for functions. When we talk about notation for functions, let's look at it. And one way that we're going to start off first with something called the function machine, and you'll see this periodically. This is kind of my machine trying to draw it. So here we go. This is a machine. What happens here, you're going to have an input. It's going to do the math here, and then when you get through doing all the math, you're going to have an output. And this is what they call a function machine when we're dealing with function. There's an input and an output. So an input and an output. Okay, same thing. I had an X and now I have a Y. We can kind of look at it like that. Okay, let's deal with, suppose, dealing still with my function machine, and I'll draw me another one. Okay, this time what I'm going to input into it, let's say I'm going to put in a 3. The math I'm going to do is 3x plus 2, and when I get through coming up with an answer, that's going to be now my output. So my input into this machine is 3. I'm going to do my math and end up with 9 plus 2, which is 11, so my output is 11. This is called a function machine. Now, a way that they write it mathematically rather than drawing this little machine, they'll use something like f of x. Now notice this is read f of x. These are not multiplied. The x is your input, just as you had here in this machine. The math you'll do, and when you get through this, doing the math, and when you complete it, you'll have, like we had 11, which is the output. So what do we have? We had the input for this one was 3. The math that they wanted us to do was 3x plus 2. When I got through doing the math, I would come out with the output, which happens to be 11. So therefore, this function is f of 3 equals 11. Notice f of 3 is equal to 11. Input, output. Let's do one more, just to make sure that you understand the concept. Okay, once again, we can use different variables. The minute you see something like this, f of x, we know we're talking about a function, which means only one input that will come out with an output. So this time, let's say we have 3x squared plus 1. So there's my function. Now, what I want to input, let's do 0 is 1. So here's my input. I'm going to do my math. Here I end up with 0 plus 1, and so 1 happens to be the output. So h of 0 equals 1. I can continue to use this standard equation that I have here for any input. I can change it, and instead of having h of 0, I can make it h of, say, negative 1. It's saying this is still my input. I'm going to use this generic equation that I have here, and this time in place of the x squared, I'm going to put a negative 1. So 5 times a negative 1 squared plus 1, which means 5 times 1 plus 1. 5 plus 1 gives me 6. Notice that's my output. So therefore, my output is going to be 6. So what do I have? My input is negative 1. My output is 6. Input, output. And this is considered a function. And notice this is called the notation for a function. Notation for a function indicates that we'll have something of some variable like this equals h of x. Right away I know that I'm dealing with a function because this is a standard function notation. I hope this brief explanation about functions is very helpful.